Welcome, dear students. You are on my classroom, and today's session is about when a hospital rule fails. A hospital rule is a very handy rule. Many problems you get them simplified using this rule, but sometimes it fails. Let us see when. So, when a hospital rule fails. What is a hospital rule? Just for a quick refresher, if you are evaluating limit extending to a f of x by g of x, and if as x tends to a, the numerator is approaching to 0 and denominator is approaching to 0. So that is of indeterminate form 0 by 0. Then this limit is as good as limit extending to a, differentiate numerator f dash x, differentiate denominator g dash x. So limit extending to a f of x by g of x will be same as limit extending to a f dash x by g dash x. This is what L'Hospital rule is all about. Okay. This is also applicable not just in 0 by 0 form, but also in infinity by infinity form. So even as x tends to a, if f of x tends to infinity, g of x tends to infinity, then also you can apply L'Hospital rule. So I'll just tell you a small example before getting into where L'Hospital rule fails. Let us see how L'Hospital rule works through this example. Limit extending to 0, tan x minus x by x cube, a standard limit, very important one. As x tends to 0, tan x is close to 0, x is close to 0, x cube is also close to 0. So this is 0 by 0 form. This is 0 by 0 form. So you can apply L'Hospital rule. So what does it say? You can happily differentiate numerator, differentiate denominator. Now what is derivative of tan x? It is secant square x. What is derivative of x? 1. What is derivative of x cube? 3x square. So this is where L'Hospital rule can be applied. And how we are applying it? Differentiating numerator, differentiating denominator. Derivative of tan x is secant square x. Derivative of x is 1. Derivative of x cube is 3x square. Okay. And can you identify secant square x minus 1? Very simple, tan square x. So this is a simple limit extending to 0, tan square x by 3x square. Standard limit tan x by x is 1. So tan square x by x square is 1. So what would be the answer here? 1 by 3. So this is a very simple rule, simplifying most of the questions. Now let us see where L'Hospital rule fails. I'll take a small example. Limit extending to 0, x sine 1 by x sine 1 by x. So before applying L'Hospital rule here, let me evaluate this directly. X sine 1 by x has two parts in it, x and sine 1 by x. Now, as x tends to 0, this x is a number which is approaching to 0. So this is what? A number close to 0. And sine 1 by x, as x tends to 0, this is an infinitely large number. Irrespective of what this number is, sign of that number will always be between minus 1 and 1. So sign of any number will be between minus 1 and 1. This is between minus 1 and 1. We call it bounded. And this is approaching to 0. So any number close to 0 multiplied by a number between minus 1 and 1, what will be the output? 0. So this limit exists and is how much? 0. So there is absolutely clarity with this. Now, how to apply L'Hospital rule here? This is not 0 by 0 form or infinity by infinity form. So for that, what I will do is, I'll just multiply and divide by x. I'll multiply numerator and denominator by x. So what will this limit convert to? Limit extending to 0, x square sine 1 by x divided by x. Now, as x tends to 0, where is numerator approaching to? 0. X square is close to 0 multiplied by a number between minus 1 and 1, numerator is approaching to 0. And denominator is also approaching to 0. So this is 0 by 0 form. Now L'Hospital rule can be applied. Let us see what happens if we apply. So how to apply L'Hospital rule here? Differentiate numerator and differentiate denominator. Denominator derivative is 1, simple. And numerator x square sine 1 by x. You can apply product rule here, UV rule. x square is one function, sine 1 by x is another function. First function x square multiplied by derivative of second function cos 1 by x into minus 1 by x square plus sine 1 by x into derivative of x square is 2x. So this is the derivative of numerator. Now how to evaluate this limit? As x tends to 0, you can see x square getting cancelled. So let me simplify this limit. What will this limit be? Limit extending to 0, 2x sine 1 by x minus cos 1 by x. As x tends to 0, what is happening to this? Close to 0. Yes or no? Between minus 1 and 1. So what is happening here? This is 0. And what can you say about cos 1 by x? As x tends to 0, 1 by x is tending to infinity. Cos of any number will always be between minus 1 and 1. So this also lies between minus 1 and 1. Other than that, we cannot say anything here. So here we are clear that this is tending to 0, but here we can only say it lies between minus 1 and 1. And whenever something you are not very clear as to which number it is approaching to, we say limit does not exist. So this limit does not exist, whereas the answer for this limit was 0. But after applying L'Hospital rule, you came to a conclusion that it does not exist. So L'Hospital rule failed here. Shall we look at another example where L'Hospital rule fails? Okay, simple limit extending to infinity. I am taking an improper limit, x minus sine x by x. Now x is an infinitely large number. In most of the cases where x is infinitely large, what we do is divide numerator and denominator by the highest power of x whatsoever is in the question. So what I'll do here, numerator and denominator I will divide by x. Numerator and denominator I will divide by x. So as x tends to infinity, x by x 1, x by x is 1, sin x is a number between minus 1 and 1 divided by an infinitely large number. So some number between minus 1 and 1, when you divide by infinitely large number, what happens? This will become 0. So this is 0, 1, 1. So what will the answer be? 1 minus 0 by 1, 1. So we are clear here. Answer is 1. This limit exists and is equal to 1. Let me see if I apply L'Hospital rule here, what happens? As x tends to infinity, this is infinitely large number, x minus sine x. Denominator is also infinitely large number. So this is infinity by infinity form. And by our definition of L'Hospital rule, we can apply L'Hospital rule here. So limit extending to infinity, I'll differentiate numerator. What is derivative of x? 1 sine x cos x, x 1. Now what is this limit? As x tends to infinity, this part is very clear, 1 and 1. But as x tends to infinity, cos x, what can we say about it? It will lie between minus 1 and 1. Other than that, we cannot conclude anything. So this part is clear, but cos x, I have an ambiguity. It only lies between minus 1 and 1 is what I can say. So the limit does not exist. Limit extending to infinity, 1 minus cos x, what I can say? This part is clear, it is 1. But here there is an ambiguity. I only know that it lies between minus 1 and 1. So limit does not exist. So again, I am coming to a conclusion, limit does not exist. Whereas I know answer is 1. So this is again where L'Hospital rule has failed us. So why is this happening? No rule in mathematics can ever fail. Remember that. So here we made a mistake in terms of learning the rule properly. Let us look at the definition of L'Hospital rule now clearly. Limit extending to a f of x by g of x, if it is of a determinate form 0 by 0, then limit extending to a f of x by g of x will be equal to limit extending to a f dash x by g dash x only if these conditions are there. Remember those conditions. Only if this limit exists. This limit exists. Only when this limit exists. That is what L'Hospital rule incomplete says. This can be applied only when limit extending to a f dash x by g dash x exists. So in the previous examples, what was happening? This limit was not existing. So that is the reason we were not able to apply the L'Hospital rule, and that was giving us wrong results. So L'Hospital rule should be applied only when this limit exists. And what are the other things which you have to keep in mind? F and d, g, they should be differentiable. and also g dash of a should not be 0. So what is L hospital rule in totality? Whenever it is a form, indeterminate form 0 by 0 or infinity by infinity, limit extending to a f of x by g of x, you can write it as a limit extending to a f dash x by g dash x, if and only if, only when limit extending to a f dash x by g dash x exists and these functions are both differentiable in the neighborhood of a and also denominator is not becoming 0. So whenever you are learning definitions in mathematics, learn them in a perfect way and only then you will not be committing any mistake. So in next session we will come out with some other very important concept and misconcept in calculus, and through next 4 weeks we will crack the complete differential calculus part. All the very best. If you like the video, like it and subscribe it.